Hello everyone, I'm Bohan from George Mason University. In this video, I will give a short presentation of our MobiCom 2020 paper, ViVo, Visibility-Aware Volumetric Video Streaming. The emerging volumetric video captures a 3D space. In the volumetric video, each frame could be a point cloud or a 3D mesh. We focus on point cloud mainly because it's simple and flexible. Just in case you have not heard about volumetric video before, let me play a video that shows the display of a volumetric video on the right and how the rendered content changes when the viewer on the left moves in 3D space. Volumetric video streaming is challenging due to the huge amount of data we need to deliver. Here is an example video with 720 Mbps bitrate. When watching this video, we will use up 20 GB data in less than 4 minutes. One possible solution is viewport adaptive streaming, which has been explored in 360-degree video streaming. The key idea is to deliver mainly content in the user's viewport. However, there are several questions for volumetric video streaming. For example, on partitioning overhead for enabling viewport adaptation and accurate prediction for 6 degrees of freedom viewport movement. In order to address the above challenge, we took the following approach. To gain a deeper understanding of volumetric videos, we first conducted a systematic study of several aspects of point cloud. To check whether we can extend viewport adaptive streaming to volumetric videos, we investigated viewport movement patterns and viewport prediction through a user study. Based on the observations from the above study, we designed, implemented, and evaluated ViVo, a volumetric video streaming system with several visibility-aware optimizations. Our experimental results demonstrate that ViVo can save on average 40% mobile data without affecting visual quality. We propose 3 visibility-aware optimizations for ViVo. At a high level, if we can predict how users move, we can determine what video content to fetch based on how and where viewers perceive it. However, viewport prediction may not always be accurate. Thus, we proposed a conservative solution that dynamically changes point density of volumetric content based on several factors. The first one is called viewport visibility. If we partition this point cloud into cells, the viewport in 3D space determines which cells are visible. Therefore, we may reduce the point density of the 4 green cells as they are likely not visible. The second one is called occlusion visibility. In this case, we know that the content in the 3 green cells may not be visible due to occlusion. As a result, we may reduce the point density of the 3 green cells. The last one is called distance visibility. Suppose the distance between the viewer and the content is 3 meters, sending a point cloud with 60% points may already be enough for achieving a satisfactory visual quality. The reason is that the size of displayed content depends on the viewing distance. To evaluate the performance of ViVo, we built a proof of concept implementation. We compared the performance of ViVo with the baseline that downloads the entire point cloud by replaying viewport movement traces collected during the user study. Let's now take a look at the effectiveness of ViVo on mobile data reduction. The y-axis of this figure is the normalized bytes of ViVo over the baseline. The lower the better. The first bar is a mixed result for 2 videos, M2 and M4, that were used in our user study. The other 2 bars are for M2 and M4 separately. Using only viewport visibility, the median mobile traffic reduction is around 35%. When combined with viewport visibility, occlusion visibility can further reduce mobile data usage by 2%. Applying all 3 optimizations results in an additional 7% reduction. These optimizations lead to no degradation of visual quality. This is demonstrated by the measured structural similarity values for these setups, which are all higher than 0.98, the threshold for lossless content delivery. The key takeaway here is that ViVo can significantly reduce mobile data usage without affecting visual quality. Please refer to our paper for the detailed design and more experimental results. Please feel free to send us an email if you have any questions.